So here I want to show you the solution, how we can solve for steady-state response to a sinusoidal input by an example. I'm going to go back to our original example that we started with. So in our original circuit, we had h of s as 1000 multiplied by s plus 5000 over s squared plus 6000 s plus 25 multiplied by 10 to 6. And let's assume that we are applying a sinusoidal input. So our input source Vg of t is equal to 120 multiplied by cosine of 5000 t plus 30 degree. So this is the input to the circuit. So this is what I have as my input. And here is my transfer function of the circuit. And I'm looking for the output, which is the voltage of capacitor in time domain. What should I do? So let's follow those steps. The first step is that I need to use the frequency of my input, which is 5000, and then plug J5000 into h of s. So the first step is that I have to find h at J5000. So it's gonna be, I'm gonna plug it here. So instead of s, I'm gonna use J5000, and same thing here. So here I'm gonna have minus j squared is gonna be minus 25 because 5 multiplied by 5, and then 10 to 6, and here I'm gonna have J5000. Obviously this minus 25 multiplied by 10 to 6 will cancel out this term. So what I'm gonna have is 10 to 6, which is the result of these 3 zeros and these 3 zeros multiplied by J5 plus 5 over 30, J30 multiplied by 10 to 6. So these 10 to 6 also cancel out. If you simplify everything here, you can see that your h of J5000 is equal to 0.236 with an angle of minus 45. So this is our first step. The first step is that you have, let me write that this is an example. So the first step is that you have to plug the frequency of your input into your transfer function, and what you're going to have at the end is going to be a complex number. The next step is that you have to use the phasor of your input. What is the phasor of input? Your input phasor is 120 with an angle of 30. So you have to use the magnitude, you have to use the angle. The next step is multiplying the phasor coming from your input and the phasor you get from plugging your frequency, J frequency, into your transfer function. So that number is gonna be, so if you multiply your h of j omega by the phasor of your input, you're gonna have 120 multiplied by 0.236 and with an angle of minus 45 plus 30, which is equal to 28.28 with an angle of minus 15. So what you have here is your output phasor, which shows you the steady state response. So if you are, so let me write it here. This is your output phasor. So it means that your Vc of t is equal to 28.28 with an multiplied by cosine of omega t. Your omega is 5000 t minus 15 degree. So this is how you can use h of j omega in order to solve. So this is how you can use in order to solve for your steady state response to sinusoidal